Our next speaker is Bryton Shang. He is founder and CEO of Aquabyte. Please join me in welcoming Bryton Shang.
Thank you. All right, so how many of you had fish this week to eat? Chances are that fish was grown on a fish farm. My name is Bryton Shang. I'm the founder and CEO of Aquabyte. We're a company based in Silicon Valley and Norway that builds software for fish farms. Our goal is to make fish farming more sustainable using software and machine learning. Nowadays, most fish that we consume are produced at fish farms. This is a typical salmon farm in Norway. Each of the pens is producing anywhere from 100,000 to 200,000 salmon per pen. Over the course of a year, this farm will produce about 1 million salmon. It's farms like this that are producing most of the fish that we eat. We've been overfishing our oceans. The World Economic Forum estimates that we've depleted about 90% of our wild fish stocks. Because of this, most of the fish that we have consumed are from fish farms. In no other industry do we hunt and gather to get the food that we eat. In fish farming, this can be the solution. If you look at global food production, it's been growing at about 1% to 2% year over year. Fish farming, on the other hand, has been growing about 6% year over year. It accounts for about $250 billion worth of food production today. If you think about the world being 70% covered by water, we only have about 5% of our food production from the oceans. 5%. This represents a tremendous opportunity for us to be able to increase the amount of food that we're producing from the oceans. As we run out of land to produce food, it just makes a lot of sense that we're going to produce more of it in the oceans. Due to depletion of fish stocks, as well as the increasing demand for fish, we're going to need to be able to produce 50% more seafood in the next decade to be able to do that. And software and machine learning can help us produce more fish. If you look at fish, it's a relatively healthy food source. It's a great source of omega-3 fatty acids. It's also rich in vitamins and nutrients. 3 billion people every day depend on fish as their primary food source. It's also in places like China and India where folks are demanding higher quality protein. Fish farming is producing a lot of the fish that's helping serve folks all over the globe. From a carbon emission standpoint and climate and global warming, fish farming can also have a big impact. If you look at carbon emissions, comparing beef to fish, beef produces almost 7 times the amount of carbon emissions as fish does. If we can figure out how to shift a lot of that production to fish, we can make a meaningful change in being able to reduce the amount of carbon emissions and improve climate change. Also, from a bioenergy standpoint, if you look at how many pounds of feed it takes to produce pounds of protein, beef is about 7 to 1 in terms of pounds of feed for pounds of protein produced. Fish, on the other hand, is about 1 to 1. 1 pound of feed for 1 pound of protein is just a lot more efficient. Now, Aquabyte's goal as a company is to be able to use software and machine learning to be able to make fish farming more sustainable. So let's put on our fish farming hat. Imagine you're a fish farmer. You have a massive pen in the ocean where you're growing some fish. So how it works, you put some little fish in, you feed it every day, and then after the course of 12 months, then you harvest the fish. So as a fish farmer, you might be thinking a couple things. One, How much do I feed my fish? How healthy are my fish? About 15% of fish die in the oceans when they're grown. When do I harvest my fish? How much fish do I have to sell? This is something that's challenging. If you stand at the side of a pen, these pens are the size like half a football field in diameter. You can maybe only see about 5% of what's happening under the surface. And ultimately, how can we make these fish farms more efficient? How can we figure out how to automate feeding to be able to make these fish farms more sustainable? These are exactly the type of problems that software and machine learning can help with. So a bit about the company. I started the company in 2017. Genesis actually grew up in Ithaca, New York, right by Cornell University. One of our family friends was a professor of aquaculture at Cornell. And then ended up going to Princeton to study operations research and financial engineering, basically machine learning. And then started a number of companies in the machine learning and computer vision space. Started off in algorithmic trading, and also was the CTO of a company that used deep learning for cancer detection. The idea for Aquabyte started when I wanted to bring the same computer vision and machine learning technology to fish farming. The idea was simple. You take a camera, you put it in the fish pen, you take images of the fish, and then be able to use machine learning algorithms to be able to identify certain things about the fish. The size of the fish, the health of the fish, how much to feed the fish. I started off by building a simple prototype. So if you can imagine me in my apartment in San Francisco, I have a bathtub, and I built a simple rig in the bathtub. I bought some robotic fish off of Amazon, I put them in the bathtub, and I started to size the robotic fish. And it worked. We were able to determine the size of the fish. Now it was time to take this technology to an actual fish farm. And this is what I realized. The actual fish farms don't look much like my bathtub. They're actually pretty rough conditions. For anyone who's worked in hardware, they know that you put stuff in salt water to destroy it. And even basic things that we take for granted, keeping the camera functional, making sure that things don't break, is very challenging in the ocean environment. Also, connectivity. These farms are offshore, they're in the ocean. Sometimes they have internet, sometimes they don't. We're also dealing with the challenge of dealing with live animals. Fish, they have a mind of their own. They respond to different environmental conditions, they'd have different behavior, and being able to understand all of this complexity and develop it into the product is a new challenge. The second thing I realized was also that 99% of fish farming is global. So again, just to ask, how many of you actually know fish farmers? Okay, well, I should talk to you after the show. Places, species like salmon, they're grown in places like Norway, Scotland, Canada, Chile. It's all over the world. In fact, Norway produces 50% of the global salmon that we consume. And after looking at the market, I decided that, well, this business needed to be a global one. And we started a second part of the business in Norway. Now, the other thing to imagine is being a fish farmer. Fish farmers, they're used to buying barges and cages and nets and physical equipment. The bigger, the better. Now imagine someone from Silicon Valley talking to a fish farmer and trying to sell software. It's a bit of a different type of conversation. Part of this was understanding how to bridge the culture between Silicon Valley innovation and Norwegian fish farming. That essentially involved a lot of travel back and forth and just a lot of frequent flyer miles. Now in 2018, we had our first fully working product. Again, to give you a sense of scale, you could take an entire 737 and submerge it in that pen. We developed a simple camera rig It's one camera per pen that goes and takes pictures of the fish. We're then using computer vision algorithms to be able to detect the size of the fish, the health of the fish, and various aspects, and provide that to a fish farmer. We spend the rest of 2018 being able to adapt this to various conditions, different weather conditions, different times of the year, to make sure the product was robust. In 2019, it was time to take it from one farm to many farms. Now, the thing that you have to realize about fish farming is that every fish farm is essentially regulated everywhere by a version of the EPA because it affects the environment, and a version of the FDA because it affects the food that we eat. To have a successful product, we needed to figure out how to create alliances between researchers and academia, between the actual fish farmers themselves, and government. In Norway, we were the first company to build electronic replacement for sea lice counting where you could actually apply to the government and use our counter to count sea lice. I'll get into sea lice a bit further into the talk, and you'll have the chance to count them yourself. We also had the chance to have CTO of Amazon, Werner Vogels, come out and shoot an episode of Now Go Build with us. If you haven't seen it, you should definitely check it out on Prime Video. It's episode number 3. Now, a bit about what we're working on. So again, we have these cameras in the pen. They're taking images of the fish, and we want to understand certain things about the fish. Now, the first thing you realize from taking these images is that while you're dealing with a lot of complexity, even just a simple task, like if I asked you to count the number of fish in the image, it's pretty difficult. You have fish swimming every which way, different orientations, you have particles in the water. It's a bit of a challenging application, and being able to do this in real time and understand the health of every fish. Now let's take a look at a single fish. Here, we're applying a convolutional neural network that's being able to detect the different body parts on the fish. We're then taking those body parts and using it to determine the weight of the fish. So let me give you an analogy. Again, for humans, we're measuring the different body parts, and like us, fish have proportions. We're using those proportions to understand the weight, and ultimately using that as better intelligence for a farmer. The way the technology works is simple. So the camera, it has 2 eyes. Like us, it can sense depth. It has an array of LEDs on the top and bottom that helps illuminate the underwater environment because it's a bit dark. You also notice that there's some sensors on the side. So we're measuring things like temperature, oxygen, depth. We're measuring other things that we can help inform our system and be able to understand how the fish are growing. We're taking those images and then we're running it through an image pipeline. So you can imagine we have an algorithm that identifies and crops the fish. We have another algorithm that filters the fish. Maybe a fish is blurry, maybe it's too dark. We have another algorithm that's able to detect the body parts. We have another algorithm that detects the weight. We have another algorithm that detects the health, and so on and so forth. We string this together into one big image pipeline that then is able to process all of the images in real time. That then provides information for a farmer, and we provide this as a subscription service. So let me talk a bit about sea lice. It's actually a parasite that costs about 25% of the cost of running a farm. There are these naturally occurring parasites. They're about a millimeter in size, very, very small parasites. And every week, for every pen, the farmers need to count this parasite. On this image, you can't even see it. It's just too small. Well, let's zoom in a bit. So you can sort of see it. Two yellow specks in the middle. And if we zoom in a bit closer, we finally see the 2 sea lice. Again, they're millimeters in size. Now imagine a fish farmer, every week, every pen, you saw what a fish farm looks like. They have to go out, they have to net the fish, They have to anesthetize them. They have to count one by one the number of fish, the number of lice on the fish, and do this every week, week over week. It's a really, really challenging problem. Our job was to make this a lot simpler for the farmer. The concept was, again, similar. We take the images of the fish. We'd be able to create object detection algorithms that could detect and classify the sea lice. We then was able to provide this to a farmer. Let's look at some infestation patterns. Here, the green line represents manual counting of 10 fish every week. Here, with our system, the red line, we're counting 10 times that every day. The farmer has better insight into infestation patterns and treatments which overall benefit the welfare of the fish. These treatments are also very costly. I mentioned it's 25% of the cost of running a farm, and having this intelligence is really important for a farmer. We wanted this to be a generalizable software platform, and we wanted to work on a number of different applications from the camera. Another thing that a farmer needs to know about their fish is how much the fish weighs. This is because as the fish gets bigger, you feed it more, and also they want to know how much fish they have available to sell. This is a picture of them using a crane to be able to weigh the fish. Again, super tedious. Our goal was to make this a lot simpler. Conceptually, it was simpler. We take the images of the fish. We then ran them through a series of deep learning algorithms that was able to detect the different body points on the fish and to be able to create a 3D model that could determine the weight. We then displayed this in a distribution for the farmer such that they could use this to manage their farm. One of the problems of building machine learning algorithms is that you need to gather training data. Now, for the underwater environment, this is a bit tricky. Let's just take a simple example. We want to build an image detector for a fish. Here we had a team of annotators that was able to detect each fish in the image and train the CNN to be able to detect the fish. Now, how about the ground truth weight of the fish? That's a bit tricky. So imagine your fish swims by the camera, take a picture of that fish, and the fish swims off. How do you know what the weight of that fish was? To do this, we needed to be a bit more clever. We worked with research institutions to be able to tag the fish, and then such that we could correlate each image with the weight. From this, we were then able to train our machine learning algorithms. Here's an example of some of the behind-the-scenes work of some of our algorithms. On the top, we're using a deep learning-based depth mapping algorithm. So again, with the stereo camera, we're mapping out the distance of every point on the image. We're then overlaying that on a segmentation of the fish. That then creates a 3D model that tells you the weight of the fish. We then applied this to every fish that we saw in the image. This then gave us a distribution for the weight of the fish. The farmer was then able to use this to determine how much to sell. So on the other hand of things, you have the Whole Foods of the world that are buying salmon, and they want to know how much they can buy each week. This technology is giving them that ability. Now again, the idea being that we want to build a common software platform on top of which we could build different applications. If you look at fish farming, about 50% of the costs is the food. They feed the fish these pellets. So if you've ever had an aquarium at home, how do you figure out how much to feed your fish? Well, you take out your food, you sprinkle a little bit in, to see if the fish eat it. Maybe they do, maybe they don't. If they eat it, you sprinkle a little bit more. It's essentially the same thing that they do at industrial-sized fish farms, just at bigger scale. So we're taking an upward-facing camera. We're watching for downward-falling pellets. So the pellets that are falling down means that they're uneaten. And if they're uneaten, they just end up falling to the seabed and end up disintegrating. Here, we're building object detection algorithms that could detect every single pellet and be able to quantify the amount of feed wastage for a farmer. So here, we're detecting 99% of the uneaten pellets. This allows us to determine and quantify how much feed wastage there is and allow a farmer to better manage their farm. Now, I want to talk about some of the cooler technology that we've worked on. And yes, like you and me, fish have unique faces. Their spots are like fingerprints. Here, we built computer vision algorithms that can extract the spots on the fish and use it as a unique identifier for a fish. So a couple of you might be wondering, what if we saw the same fish twice? Well, we know that. We also know how individual fish grow over time. Now you can imagine going to a nice restaurant, you order your plate of salmon, you take out your phone, and like a QR code, you found out exactly how that salmon got there. Now combine that with the blockchain, and you literally have full traceability of your fish, literally from farm to table. Now, the holy grail of fish farming is a fully autonomous farm. The idea being here is that we can use a lot of the information that we generate from the images to be able to adjust how much feed is given. So the idea is simple. Let's just imagine that we're running lots of different A/B experiments. So let's just run an experiment where we have two identical pens, except in the second pen, we feed it a different type of feed, and that's 2 to 3% more efficient. And over here, we run another experiment where we have two identical pens, but one maybe we feed twice a day instead of once a day. We can then run lots of different A/B experiments to figure out what is the optimal policy for feeding our fish. Aquabyte's goal is to eventually build fully autonomous fish farms. In Las Vegas, if you eat a fish here, it needs to be trucked in from the Pacific Ocean or it needs to be flown in. Imagine having an indoor fish farm miles outside of the strip where it's fresh fish, it's more environmentally sustainable, and it's more economic. Right now, the main problem is that most of the fish farms need to be by places where people can actually go to the farm. With automation, we can start to have indoor fish farms, and we can also have farms in the open ocean. Eventually, we'll be able to get here. Now, to be able to do this, we need to learn to process a lot of images. So to give you a typical sense, every one of our farms, we process about 1 million images a day in real time. Now for us as a startup, we've been around for 2 years, we have about 10 customers. For those 10 farms, if you do the math, we're processing about 10 million images a day, or about 1.5 petabytes of images every month. That's a tremendous amount of images. Now imagine going from 10 farms to 10,000 farms. To do this, we're going to need to build a lot of new knowledge, new alliances, and new infrastructure, and it's going to have all of you to help us to do that. We need to start on the cloud, and then we need to figure out how to scale to the edge in places where there's low connectivity and to make the processing more efficient. We need to figure out how to automate more of our algorithms and be able to do that such that we can process a lot more efficiently. By 2030, there's going to be 1 billion more people in the world. Aquabyte's goal is to be able to make fish farming more sustainable. Again, with the world being 90% covered by water, or 70% covered by water, we only have about 5% of our food production from the oceans. That's a tremendous opportunity for us to be able to increase the amount of protein that we're growing, and in ways that are a lot more sustainable. It's going to require the help of all of you to be able to build technologies that can be able to process images more efficiently. I hope you can all join me in being able to make fish farming more sustainable, and together we can figure out how to sustainably harvest the oceans for generations to come. Thank you.